Hi everybody, it's Adam Heaney with Mueller Technologies. I want to apologize about it being so long. It's been about a year, I think, since the first video on web applications and communicating with a Beckhoff runtime. It was our first year of business. It was unbelievably busy. And we're in our new shop now, so we've got to get that organized and laid out. But I wanted to take some time to make a follow-up video to the first video. Now, if you look back, and I'll have links in the comment section or in the description, the first video was mostly about, this is kind of what web technologies are and how they, web servers, JavaScript, HTML, CSS, and then how we would communicate with a Beckhoff runtime. And I want to clear something up because it wasn't the intention to show you how you should be interfacing with a TwinCAT runtime. The first video wasn't. It was just kind of showing you what's going on behind the scenes to get, a web document or web application to communicate with symbols, and then those symbols to give you feedback into your web application. That's not the way that you should be designing your projects. Using I think it was the TCADS JavaScript file and the DLLs and the SOAP messaging, that was just kind of show you that what's going on behind the scenes isn't magic, and it's technologies that have been around for a long time. And while there's abstraction layers that make it sometimes difficult to see, hey, how is this button on the screen getting to my runtime and affecting symbols? It was just to kind of show you a behind the scenes look. And that was really the foundation for what we're leading into, because today's video is going to be about Beckhoff's TE2000, which is the HMI engineering environment. That's what's integrated into Visual Studio when you install the TE2000 engineering environment. And then also to talk about how we build web applications using the HMI engineering environment. And it's going to be much sleeker and much more well tied together using the TE2000 engineering environment than trying to hard code a web page yourself and get that to talk via ADS to a runtime. So the objectives for this video is, one, to introduce the HMI engineering environment, to introduce Beckhoff's TF2000, which is a function package that you install, and that is the actual production server that you will be hosting web applications on. Then I want to look at the underlying code that allows us to realize elements in our HMIs, like buttons, graphs, event logs, different colors, like how we change colors in different images and different shapes on a screen. Then to look at the underlying code that makes up those controls that you see on a screen. And then to look at the major aspects of a TE2000 project. So basically if you were going to create a web application to deploy, to talk to a Beckhoff PLC, the kind of settings that you would need to go through. So that's web server settings, configure your HMI extensions, your user controls, your default controls, or your vanilla Beckhoff controls, content files, views, on and on and on. So I kind of want to walk through that. So a high-level overview of Beckhoff's TE2000 HMI engineering is that the development environment is, like I said, it's integrated into Visual Studio. So if you go to the Beckhoff website, you download the TE2000 installer, you install it. What you're going to get is a code base, and that is what's being installed inside of the XAE, if you're using the XAE, or if you're using Visual Studio 2019 or something else. And that's going to allow us to create web applications with HTML, CSS, and JavaScript. And we can do it from a hard-coded perspective where we're writing the code ourselves. But in general, we're going to be in a modeling or a graphical environment where we're dragging and dropping controls onto the screen and acting on properties, adding events. You can hard-code it. You can do a traditional web development approach, but it's not really set up for that kind of workflow. We have views, content, image files. That's kind of how the structure of a HMI engineering project is set up, where it's similar to traditional web development, where you have some folder where you have these different, a view is an endpoint or a URL that you're going to go to. It's a page, and then content would be things that fill regions in those pages. Images, or obviously images that we would load onto that page. So it's kind of structured the same way that if you're coming from a traditional web development background, it might seem similar to you. The major components of an HMI project is the settings for the target system. So what PLC do you want to talk to? What runtime do you want to talk to? Or what runtimes, if you're going to have one central HMI web server that is communicating with multiple targets. We need to configure our web server, whether that's security, certificates, endpoints. What URL do we want plant floor operators to type into their web browser to target our web server where we're hosting the web application. Event logger information, because there's an HMI extension that will pull data from our runtimes and make that available to a control that's on the screen in an HMI. So you can see, hey, I've got these messages, I've got these alarms that I've created in my PLC, and now they're visible in a nice pre-packaged format in your HMI. Then we're going to look at the code that makes up all these control elements. So these buttons, input fields where you can enter strings or you can enter integers, charts, all these things. We want to see, how is this constructed? Like, yes, I see on the screen that I can drag and drop this control over, but what makes that up? How does it work? So we can kind of get a fundamental understanding of what's going on behind the scenes when we're building out these applications. And then with the TE2000 HMI Engineering package, you get a piggybacked in that install is a live, or what we call an engineering web server. And what this allows you to do is, as you build out your HMI, you can immediately go into live mode, and this non-production web server will spin up, and that content will be pushed out to that web server. And so this page that you're building, or this web application you're building, you can test it in real time. You can see, hey, when I click this button, I want to change this color. Is it operating the way that I think it's supposed to operate? And so the engineering web server is not a production web server. Production web servers are licensed under the TF2000 function package, but the engineering web server is integrated into the XAE shell or the TC3 HMI engineering suite, so that you can, in real time, test out your code and your HMIs that you're building. And so the workflow that we have, like I kind of addressed already, but we're going to create an HMI project. We're going to test it against our real-time PLCs. So if you've got, if you have actual controllers that you're running, or if you're just testing it locally on spinning up a VM or spinning up an instance of a PLC on your computer, you can test that with that target system in real time. Once we're satisfied with the web application that we've built, we're going to build and publish that project, that HMI project, to the actual production web server. So we're going to have the settings for that web server, what's its IP address, what ports are we operating on, is this using HTTPS, or is this just using non-secure HTTP, are there certificates, all that kind of stuff that goes into it. And once we've got that configured, we will publish all that data to the web server. And now our production web server is hosting this web application, and any web browser can type in the endpoint that you've configured or the URL that you've configured, and you can view this HMI application. So as I mentioned, we have TE2000, which is the engineering environment, and then we have TF2000, which is the licensing format for your production web server. And so I want to go over kind of the high-level details of the TF2000 package. It's the web server that's going to host our applications. It's going to communicate with our target system. It's going to deliver our web content to clients. So any device that is connecting to that endpoint, it's going to deliver that content, and it's going to handle the interactions from that client to the server and then to the target systems that server is connected to. The licensing model is, when you purchase TF2000, you get one target system connection and one web client connection included. So if you've got one PLC that you want to connect to, and you're going to have one web browser at all times that's connected to that web server, that would suffice just to get the base TF2000 license. Then there's optional licenses for if you want multiple TwinCAT runtimes connected to one web server. And then there's also option packages for if you want more than one client connected to that web server. And so if you're doing kind of like, Beckhoff has been very heavy in like OEM development. So a lot of times TwinCAT runtimes are used in machine builders that they ship one PLC or multiple PLCs, but there's only one HMI for that entire specific custom machine. Maybe you only need the base package of one target system and one web client. However, if you're looking to kind of get more of a distributed control system where you have a central HMI server that is talking to multiple clients plant-wide and you want to get an overall view of your plant, then you can look at those different licensing models to get the exact number of clients that you need and the exact number of target systems that you need. And this also opens up the idea of redundancy because your web server settings can be local or remote. So essentially that's saying that, hey, is the project that I'm publishing to this web server, is this the local configuration that's going to be talking to target systems? Or do I also want to talk to another web server? Do I want one web server, like a primary web server that's going to be delivering my applications to the web clients? And then maybe I want to talk to another web server that's my backup. So if my primary fails, I can switch over, my clients can then connect to my backup. So there's different ways that you can organize the architecture, and it reflects what most other companies have been doing for a very long time. This is just IT and web infrastructure setup, and I don't claim to be an expert at that. So, but the idea is, do you want a central server that's talking to clients, or do you want redundancy? Do you want maybe a bunch of edge clients that it's you've got multiple specialized systems out on a plant floor and you want an HMI for each of those, and those will be individually licensed and those will be individual web servers and they'll just talk to one another? Or do you want more of a centralized system where all of these target systems, all of these PLCs are communicating back to one or multiple central web servers? And then another part of the TF2000 functions is the extensions. So there's a list of official extensions that you can look through, like the TcHmi event logger, the the SQLite historize. And these are kind of add-ons that you can install for free that give you some functionality. So the SQLite historize is a ring buffer that you can set up for each symbol, how long you want to retain the data on that symbol, and the interval at which you will record that data. And then you can use that in the web applications to show charts, to show trends, all these kinds of things for troubleshooting. It's really helpful, in my opinion, for troubleshooting when you're in commissioning, to have a state machine that you can look at the states that your machine is going through as you're commissioning. And those are free. The TcHmi event logger is free also. That connects you to a target system's event log. So you can pull off alarms, errors, either user generated or system generated. So, the terrible things like page faults, that was probably going to crash your system, but anything like that will be fed back to the HMI, and it can be natively displayed and filtered in the event grid control that Beckhoff provides. And then there's some paid for or licensed extensions, like the OPC UA extension, which would allow you to connect either to run a native OPC UA server or to have a third party like a Kepware or something like that. There's also a scope extension that will tie in the HMI to Beckhoff's scope and measuring function packages. So the fundamental purpose of an HMI is to connect a target system like a PLC or an intelligent field device to a larger control network that you can supervise and operate on. And so that means that we have to get variables in the PLC into our HMI. And so the way that we do this in the HMI engineering suite is that we map these variables. We map symbols from the PLC to the HMI server. And this can be accomplished in two ways. So one of the ways is that you can be connected to your target system. So your runtime, your XAR can be in run and started. And you can look in real time via ADS to basically see all symbols that are defined in the PLC. And then you can map those into the web server. And there's other options. You can do things like edit permissions, so it's read-write permissions or read-only, write-only. The other way that you can do this, if you're not connected to your target system, like let's say that you're working on a workbench and you don't have a PLC, or you don't, for whatever reason, you can upload a TMC file from the PLC. So you can have all of those symbols defined in a PLC or a previous project, and you just want to duplicate that project. You can bring that TMC file in, upload it, and now all those symbols will be available to be linked to the HMI server. And mapping symbols has multiple advantages. One of them is that the server creates and verifies data types for symbols. And primarily this is important for custom symbols. So custom structures, enumerations. When you map a PLC variable to an HMI, you get all the data all the data with respect to that symbol. So like enumerations, for example, you can natively in the HMI environment use the different enumeration values. If you're bringing in structures from like structures, let's say that you pass into function blocks, all of those are pulled in natively and you can use them as the structure object. You don't have to worry about setting up controls off of each Boolean in a multiple Boolean structure. So it's really nice with respect to that because it allows you to down the road, what we'll see is that kind of approach, that kind of architecture where you're using structures, you have repeatable templates in your PLC code, well, those transfer really well to templating in your HMI, which cuts down on development time. It makes testing much easier. And then it makes people look into your code. It's much easier to troubleshoot because they see the same kind of patterns repeated over and over and over again. And then also mapping is a prerequisite to use the SQLite Historize extension. So you must map a variable from the PLC to the HMI if you want to save it in the ring buffer to use in trends and charts and things like that. So that's the major advantages of mapping the symbols. Instead of reading them, through ADS in real time, I prefer to map them and have them on a schedule, like some interval either on change or at some periodicity based on what my PLC can handle and how many symbols I'm trying to map back and forth. Okay, so something that's going to come up again and again is the TcHmi Framework. And so when we start looking at controls, and a control is any object, any element that you're going to add to an HMI in the engineering environment, we call those controls. So buttons, input fields, keyboards, any of those on-screen devices that have some functionality, that's a control. And then there's subsets of those, like a user control is a type of control that's customized by the user. So that's where we get into templating, and we'll look at that in a little bit down the road. But all of those live under the umbrella or the framework of the TcHmi Framework. And so what is a framework? Well, Wikipedia defines a framework as, in computer programming, a software framework is an abstraction in which software providing generic functionality can be selectively changed by additional user-written code, thus providing application-specific software. So it's a lot of words to basically say that a framework is scaffolding that has been developed by a team of developers that has been vetted, hopefully vetted, and that allows you to kind of do away with the lower level programming and immediately get into quickly creating functional systems that do what you, functional and complex systems that do what you want it to do. So the TcHmi Framework is the underlying code base that realizes the graphical objects that we see in the TE2000 web-based HMIs. So while the engineering environment presents you with a what you see is what you get or WYSIWYG development environment where we're dragging and dropping these controls over, underlying those controls is JavaScript prototypes, also called classes, but I guess technically they're prototypes. So underlying all these controls are JavaScript prototypes that are defined in the TcHmi Framework. And this is an important nuance to acknowledge because it helps understand that the events and properties that we are editing in the development environment, which we'll see in a little bit, these events and properties of controls, that those are analogous and identical to writing code in JavaScript for an event listener or modifying object properties in JavaScript. So realizing this allows us to make two distinctions. One, while in the engineering environment, I'm going to say when I on touch or on press, when an operator touches this button on the touchscreen, I'm going to cause some action to happen. Well, really, what's going on is the TcHmi Framework for a button has added an event listener on touch. And you're just procking or you're just triggering that event listener that then you've written some code for to do what you want it to do. And then they handle that in the background of, okay, event listener has been triggered. Let's do this thing that they have then programmed. And then also the other thing that's really important to recognize is if you're going to write like custom or just write plain HTML in the development environment, certain elements that you're used to in HTML, those properties don't necessarily exist on, let's say, like a button, for example. A button in HTML will have some functionality that a button defined in the TcHmi framework. So a TcHmi.controls.button, it's its own object. It's its own prototype. So it might not have the same type of functionality that you're used to. And that kind of tripped me up early on as I was writing kind of naked HTML, and I was writing JavaScript functions to act on those. And I was like, well, I know this is an action that I should be able to do, but it's not working. Well, and that's because I was using a TcHmi button and trying to act on it with straight up HTML functionality. And so those are important nuances to understand. So we get to controls. So controls, as I kind of alluded to before, is the term used to represent all graphical objects and their underlying logic used in a HMI project. So essentially, like I've said before, controls are like prototypes. And when we place them in an HMI object, we have instantiated, or an HMI project, we have instantiated an object of that prototype. And because of this, the objects must have unique names throughout the project. So when you drag and drop multiple buttons, or if you copy and paste a button that you've created on one screen, you're going to see that there's a unique identifier, usually an integer that just is incremented, that goes to the end of that name unless you change the name. Because we have to have unique identifiers throughout our entire project. And so every control has 3 distinct workspaces where we parameterize and customize that control. And those are properties. Usually those are visual. Sometimes they're not visual though. In the case of like an image has a property. Well, where's the file path to that image that I'm going to display on the screen? That would be a property of an image. Most things have, borders, colors, all these things are properties of a control. Then there's an event workspace, and that's where we're basically modifying event listeners. So on attached. So when that control is instantiated for the first time in an HMI, do we want to do something? On touch, on mouse click, on loss of focus. Those are all under the event workspace. And then there's a permission workspace that you can get into if you've got user groups. So if you set up user groups in your HMI project, then you can say, well, certain controls, you have to have this level of permissions to act on, and maybe a lower level of permissions, you can't act on it at all. Okay, so let's get into the engineering environment and kind of look around, and I'll show you the major components of how you would start building out a project, and just kind of diving into a demo project that I put together that's very similar to the first video, so we can see how you can more rapidly and robustly kind of create the same kind of project with motor control and some trending like we did in the first video, and hopefully it'll be much easier. It will be much easier because so much of the code has been abstracted away by the TE2000 and the HMI framework that comes with the engineering suite. So as we get into our HMI project, if you look through our solution, we have the traditional TwinCAT project that has all of our system, our PLC, our motion, safety, I/O. And then what I've done is I've added in the solution an HMI project that we see up here. And the way that you would do that is you right-click, add new project, and then you're going to get an idea of TwinCAT HMI project generator or project. I usually just use project, and there's also a framework option down below. Okay, so I've added a project, and I've actually gone through here and filled a lot of stuff out to show you in a demo. But I want to go through the major parts in the beginning of how you would set this up. So if we click on our server, we've got these different parts over here of our our web server configuration. And so the first one is our ADS. So if we go to ADS, this is our communication protocol that we're communicating with the Beckhoff runtime with. And so this is where you would parameterize the values for your AMS net ID, the port that you want to communicate on with, which is 851 for most PLC tasks. And then you get live diagnostics here. So since I'm running this locally, I can go into PLC1. I see that because my runtime, my XAR is in run, that I've got good communication. And so this is the ADS portion is where you would set up your communication to your PLC. And if you're connected to a target system, this is done kind of in the background for you. It's populated here. It shows you the available runtimes that you've either previously connected to or that you are connected to. Your server is the next drop down, and this is getting into the web server. Like, okay, what do you want to call it? What extensions are installed? And right now, I've got the background extensions that are installed in every HMI project is ADS, the HMI Lua, the SQL logger, and the user management. And then I've installed separately the TcHmi event logger and the TcHmi SQLite Historize. And as we drill down into these, you can see more information about them. Configurations, you've got remote and local. That's kind of a topic for another time. And then as you go through here, you can just, there's all sorts of data that's on here. One of the things that's probably more important to pay attention to is your endpoints. So your endpoints is where you're going to actually publish this information to. So the endpoint is the URL the URL for the system, or the IP address plus the port for the system that your production web server is going to be on. And when you target that, when you actually publish to your web server, this is where it's publishing to, these endpoints. And then via the browser, it's these addresses that you would call up to display your web application. And so usually there's two. The default port, I think, for unsecured HTTP is 1010. The secure port is usually default 1020 for HTTPS. And then this is, these are just set up because I've installed multiple. I have both the engineering environment and the TF2000 installed on my computer. So if you look down in the lower right-hand corner, you can see that I've got two web servers actually running. I'm publishing to 5000, so that's what I'm treating as the TF2000 production web server. And then this is my engineering server down here, this port 3001. That's my live view. So my engineering server, when we get into later and you see the live view, that's the server that is being called for displaying the real-time, my HMI as I work on it. Your event logger, that's the same idea, target systems, local AMS net ID. So it's the same idea as your ADS communication. Then you've got diagnostics to look through. Okay, yeah, I've got 22 imported events because for the demo project, I wanted to show you the functionality of the event grid. And so I created some messages. And so you can see how many alarms you've got, how many events you've got, how many messages you've got, and the overall connection state. And then your SQLite Historize. And so this, this shows you the number of symbols that you have history set up for. And so it looks like I've got 6 symbols that I've set up history for, and the periodicity that's on them. You can see that the maximum number of entries and the interval time. So PT1S, that's 1 second. Every 1 second I'm grabbing information, and this is a structure. And then maximum number of entries is 10,000. So these kind of parameters you need to tailor to the capabilities of your system because, like I said, a lot of times these are OEMs that are building front ends or web applications for a specialized machine. And if they're using exactly the amount of hardware and RAM, CPU power and RAM that they need to get the cycle times and the data processing that they need, you need to be careful about how much overhead you're getting tied up in saving historical data, because this is a ring buffer and it is using RAM. And so it's just something to think about as you do this. So you could calculate out, okay, I've got this structure. I think this structure, I'd have to look at it, but I think it's maybe like 3 Booleans. So, 3 Booleans at 10,000 entries, you can start calculating up how many bytes of data you're taking up, on and so forth. So you can get an accurate idea of how much data you're really going to be using and how much overhead you're going to be using when you start, logging a bunch of symbols in the ring buffer. Okay, so those are the primary sections that you need to read in the manual and configure to publish a web application that you develop. So an HMI project, these are the main things that you need to have set up to: 1, ADS, talk to your target system; 2, web server addresses and passwords and all that stuff to actually publish to your web server; and then doing configuration on your extensions for the kind of functionality that you want from those devices. Okay, so the next thing that we're going to look at is kind of this tree over here, which is mostly the things you're going to be most concerned about are your content, your images, any custom JavaScript functions that you're going to create to do work in the background for you. Keyboard layouts, those are important if you're using a touchscreen where you have an input field and you want to bring up a keyboard so a user can enter values or text if you're dealing with strings. Localization, if you're going to have multiple languages, that's where you would configure your localization settings and how you switch between different languages. And then your view. So by default, when you install when you create a new HMI project, you get a default view of desktop. So desktop.view is the default view. And to kind of make sense, if you're coming from maybe a different HMI environment, in web applications, you usually have views or pages which represent at some endpoint. There's usually a / and then there's different pages, right? Your home page, your about me page, whatever. Those are different pages. And then within that page, you can set up different content regions. And that's really the workflow that we're going to use in the HMI projects, is we're going to have some views. And making a decision on how many views you want is going to come up based on how you plan on your operators using your HMI. Maybe you want 2 views because you're going to have 2 web browsers open or 2 tabs open that are both targeted to a different view, a different URL endpoint with the / and maybe one's on home, maybe one's on alarm status or something, and you're going to display those on 2 different monitors. Or if you're going to have like a touchscreen basis where you want to be in kiosk mode where the operator can't navigate to other URLs or they can't do any of that stuff, you might just have one view. And then what we'll do is we'll have regions that we define within that view. And then what we're doing is dynamically pushing different content into each of those regions. And that'll make sense in a second when I show you how we've set this up. So let's look at the desktop view. So the way that I've set up this desktop view is that I've got a navbar region and a main region. And give it some time to load. And so the reason why you're seeing data right now, and I'm going to bring this down to 80%, the reason why you're seeing data right now is because I've told my main region what I want my default content to be. So on startup, it's always going to load my default content, which I've defined as my motor content. But just to break this down, if you're familiar with web development, you have a thing in web development called the document outline, or the DOM. And the DOM is the object that is a hierarchical tree structure of all the HTML elements in a web page. And the document object model is what JavaScript acts on. It's what we interact with to manipulate things in a web page dynamically. It's also how we structure the hierarchy of elements in a web page. And so if you you can see right now I've got my document outline up, but you can also bring it up by going to TwinCAT HMI and then Windows. And these are the primary different windows that are part of what they call the HMI Engineering Suite. So right now that's the document object model. So I've got that brought up. The document outline, which is showing you that basically it's a simplified version of the DOM. And you can see that I've got 2 regions defined. And I know that this is a region. I'm going to make this much smaller, as you can see on my tiny screen. This right pane over here is your primary workspace for parameterizing all controls that you're going to put in a view. So this is what I was talking about earlier with controls, where we have our properties, we have our events, and then we have our permissions. So every control has these 3 workspaces that are tied to it. And then you can see my unique identifier at the top. And I know exactly what type of control this is because it tells me in the framework TcHmi, it's a control, it's a system, and it's a TcHmi region. So right here is what I'm clicked on, which is my primary content region. And this is what I'm going to, when I want to go to different quote unquote pages, which are not really pages, it's different content that I'm moving into one page, one view, which is the desktop view. That's what I'm dynamically changing, is this region right here. And then so at the bottom, you can see this other region is my navbar region. And so this is going to stay up all the time. I'm not going to change this because I want this, as we click between different content, I always want my navbar there so my operator can switch back and forth between these different content regions, which to the operator is probably going to look like web pages, but it's the same web page, just different content. So sorry for belaboring that point, but it's an important thing to realize in how you're going to make these HMI projects. And you can see that by default on my navbar, my target content under common is, if we click and explode it out, let me bring this over here. It's going to show me all the content files that I have. A content file it's a .content extension. And so that's what we push into regions to then display in views. And so it shows me, it filters out, it says, okay, I've got an event log content, a motors, and a navbar content. And so I've selected navbar. And so that's the default content that's going to come up, is this navbar content right here. And so to look at that, if we go over to content, because right now we're on a view, we're on a desktop view, and this is an 800 by 600 viewing size. If we go to content, you'll see that like navbar, for example, has been set up to fill exactly the pixel width and pixel height that I've defined for the navbar region. So the content that I've chosen to display in the navbar region is the same size as the region itself. Now you can use percentages, which most people will use because you might be doing development for different screen sizes, for mobile, for desktop computers, for widescreen aspect ratios, whatever. So I'm not an expert web developer. I'm certainly not an expert front-end developer. So a lot of those people have a lot of experience with using percentages, percentage padding, so that regardless of the viewing screen that their HMI is observed on, it's formatted nicely, it's displayed nicely. I haven't done that. I've used static dimensions for everything. But you can see that this navbar content file is then made up of other objects. So this content file is made up of a rectangle control, which is this black banner. And then I've got an image for our logo. I've got a button. I've got 2 buttons, actually. And then I have the TcHmi state, or the ADS state. This is a cool little feature. It's just a control that Beckhoff bundles in. And behind the scenes, it handles showing you the status of your TwinCAT runtime, your PLC runtime. So if it's green, that means your PLC is in run. And if it's red, then it means that it's stopped. And if it's blue, obviously, then it's in config mode. So that's the primary approach that we're going to use to developing a view. We're gonna partition up a view into regions, and then we're going to dynamically change the content of those regions based on interaction with buttons or however you want to do it. So I'll go back to this navbar and I'll show you that what we're really doing is when an operator clicks on the motor button, if we go to our events, because if we were doing this straight up web development, we would add an event listener for on click or on touch or on pressed or whatever. And so you can see here that the framework, the TcHmi framework, has already done this for you. It already has an event for on pressed. And so I've configured that event. And what I've done is if we click this little pencil, we can see what I've done. All I'm doing is I'm writing to a symbol. That symbol is the region. So the unique identifier region main content, which I've already defined. You can find that over here in your left pane where all your controls that are either in scope or out of scope are displayed. And so I've said under desktop view, I've got 2 regions. Well, when I click the motor button, I want to show the motor content. So I went down to my main content region. I expanded that. Then I go to common because that's where my target content is. And I dragged and dropped this over. And then I just selected the content that I wanted displayed. And so if I hover over this, you can see that it's region, main content, target content. That's the control and the property of the control that I'm acting on. So target content is the property of the control region main content. And I'm setting it to the value of, okay, I want you to display the file motors.content. And so that's all I'm doing. And that's just repeated throughout here is how we use event listeners to trigger events that are dynamically changing properties in our controls. That's the primary task that we're doing when we're changing the HMI. And then the corollary to that is when we're changing the value of symbols in the PLC, we're triggering events that are writing to mapped symbols in the web server that are tied to a symbol in the PLC. So that's basically the approach that we're going with, or at least that I went with. I'm sure there's smarter people that have much better control schemes than that. And so I want to show you in a second this event listener and all these properties that you see in the GUI. I want to show you how these things came to be and what really is behind these properties and these graphical fields in the code that is actually constituting these different controls. So like this button, for example, we're going to take a look at what makes up a button, where the root code lives that makes up a button control in the TcHmi framework. Okay, so now I want to show you the code that's behind these graphical objects. So I've already found the file path where for this project all the code is stored. And if we look at the file path, well, I didn't do what I wanted to do. We can see that it's actually stored in that when you add that HMI project to your TwinCAT solution. What happened is all that framework code got put into the project that you created because these are the controls that you're going to use to build out your web application. So if you drill down into wherever you save that solution, you'll eventually come to the code for the TcHmi framework. And so right now we're in the button. You can see right here where it says TcHmi button. We're in the folder that is containing the code for the for the control button that comes from Beckhoff. And you can see that this is really similar to what you're used to in web development where we've got a style. So there's a CSS cascading style sheet file that is saying, hey, the default values for fonts, colors, weights, all that stuff for a button control is defined here. And then there's a TypeScript file. There's also then the JavaScript file. So if we open up the JavaScript file, this is how we know that what we're really working with in the graphical user interface is essentially what you're doing when you're building out straight up web development. And it's important to realize this because it makes things, if you have some experience with writing JavaScript and working with web pages, it will kind of make sense to you what's going on in the back end. And then that leads to a better understanding of non-blocking behavior, the call queue, the event queue, which most of this has all been abstracted away with callbacks that Beckhoff already has programmed in here for you. But it's just interesting to see. So anyways, you get this gobbledygook of code. You get this long list of code. And I imagine, I don't really know, but I imagine it's done this way to kind of, keep people from nefarious deeds. But as you look through here, you can start seeing some keywords that make sense. So for instance, we can see a event listener. So yeah, event listener on mouse up. Remove event listener on mouse down, on touch start. So all these properties that are in here, so we can see that what's going on is essentially the framework has done all this work for us in JavaScript that you're now being able to act on in the properties and events workspaces in the XAE, in the engineering environment. So that's just something I wanted to show you because I think it pulls full circle, it brings full circle what we're doing when we're working with the HMI engineering project. It's essentially web development with a very nice user interface. And then also from this, we've been working in the in kind of the gallery view. But if you go to design, if you click on this little button here, it should take us to, it's going to make a liar out of me. You click on HTML, and you can see that, this is the HTML file that's being created for this content page. So if you wanted to write, your HTML, you could do it here, but this is essentially in the design workspace when we're dragging and dropping controls over and we're editing these properties to change colors, to do all these different things. Behind the scenes, the HTML is dynamically changing to reflect our changes in the design workspace. Okay, so that's that. I guess I should show you an overview of your user controls. Let me bring up the motor content page. So in the motor content page, you can see that the background is transparent, and that's because on my view file, I set up what I want the background to be, because I'm changing content, because I'm changing the content in the main region in the view file, I want to have a nice, homogeneous, consistent background as my operator goes through different quote-unquote screens. So I've left this transparent because that's been defined in the view file. If we look over here at the toolbox, I'm going to reset the toolbox. If someone could tell me why it does this, I'd be very grateful. Sometimes it just Visual Studio can't figure out where your controls are, and so you've got to reset the toolbox. But up here you can see my user controls. Now, user controls are a subset of controls, and user controls are basically what I like to call templates. This is where you get really into templating and quickly spinning up HMI applications is by using user controls. And so those are the first ones that are displayed, and it's under the heading of HMI demo because those are user controls that I've created in this HMI demo project. As you can see over here, the name of the HMI project is HMI demo. The other great thing that I'll bring up is because all of these are files, if you create a new project and you don't have like a template project, if you just finished one job as an integrator, you've got another job and you want to bring over a lot of that code base that you've already worked on, because these are just files, it's really easy just to open up your new HMI project and copy and paste these user controls or these content pages or whatever they are over to your new project. And that is really nice because it really cuts down on development time. So back to these controls. So in our toolbox, we have all of our controls, pointer, button, checkbox, combo box, blah, 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 all the way down. Then we've got charts, which is their controls. It's just under a different heading. It's charts. I'm using the trend line chart for both of these graphs right here. And we'll see that in action later in the video. And then this ADS state control is what I was telling you is the little green box that shows you the state of your ADS connection to your runtime. So it's the ADS connection state to your PLC runtime. And then there's images. You can bring up images like this. This is actually a user control right here. And you know this because if we look at our document outline, I click over here. I see it's highlighted the UC motor control. If I go to properties, I can see that the type is UC motor control user control host. That means it's a user control. I've created it. It's a template. And I've instantiated this template here, and I've given it the name UC motor control. And you'll see how this is going to allow me to switch between motors 1, 2, and 3 and dynamically change the values both of the status from the PLC and the commands I can send to the PLC with respect to each motor. And that's why I've done this. And then you can see if I click over here, we've got a trend line chart, another trend line chart, And then containers. Containers are just nice ways to create a new, what I would call a reference frame in robotics, but it's just a container groups together controls in a new coordinate system. So as you are dragging and dropping controls into a content file or a region, you're going to have pixel coordinates, and I'll show you that here. If we go to properties and I click on this text box, it says that the top left corner is at 0, 0 in pixels. So it's 0, 0 on my content file. It's got a width of 100% and a height of 45%. Well, as you start working down a page or into different areas, it can be difficult to get exact spacing, exact locations when you're dragging and dropping things. So when you create a container, it easily groups together like devices, and it also resets for the children of that container. It resets the coordinate system. And even deeper in this, we can get into classes, which are similar to classes in CSS, where you can have different colors, different weights, different drop shadows, all these things associated with a class name. And you can give all of these controls have a class name property, which you can see right here, class names. And if you've defined different classes, you can give that control that class name, and it will have those CSS styles laid onto it. And then a larger concept that can go on later is themes. So on the left-hand side over here is themes. When you install an HMI project, it comes with the base theme. There's a base light theme and a base dark theme. And those are basically working on their default classes that have been created for the different controls. But you can create your own custom themes, and that makes it really easy for every object that you drag over. If you're using a custom theme, instead of having the default CSS values for a button or a text block, it will use those custom theme values. So your colors, all that stuff will natively come over, and you don't have to mess with any more, changing the properties of those controls as you drag them into your HMI. So yeah, many controls have the same properties, the same fields, but based on the control type, they will have different ones. So obviously, a text block is going to have a text field where you can enter the text field that you want displayed on the screen. A button will have a text field for the name that you want on the button, but it will also have other things on it too. An image will be the same way. So familiarizing yourself with the manual that shows you what properties each control element has is helpful. Also, the different events that can be triggered on that control element is useful. Another really cool thing that I like that I've done for robots is, for example, Fanuc robots. Most of them come with a native web server. And so that web server is hosting a default document that shows a default document with some different pages that show really cool stuff. Shows you summary of your pack codes for your Fanuc robot. It shows you the major software, the build version, all that stuff. And it usually has a alarm history that you can look through. It's got cool stuff that you can view on it. And the great thing is that with, I believe it's the, you're going to catch me lying, but I think it's the, iframe. If you bring over an iframe, you can target that to an endpoint, a URL, and that will show inside of your web browser. So that's what we've done recently with a robot project where we wanted to, in our TwinCAT HMI, we wanted to give the user the ability to look at the web server on the Fanuc robot. We used an iframe and we targeted that URL endpoint. So really nice features, and just getting yourself familiar with them is what's going to unlock the ability to create really awesome web pages. So I should have done this earlier, but I will show you now everything that I've been discussing and talking about. What that came together with is this HMI right here. So let me drop all this out. So this HMI, I created a little program with 3 motors, function blocks. There's a TC event logger object in the PLC code. There's some messages, but largely it's just starting, stopping a motor, resetting the fault on a motor, and then I've written some simulation code to change the temperature when the motor is on. Temperature goes down when it's off. So we'll just see it in action right now. So we're on motor 1. if you'll remember, this is the user control I was talking about earlier. So this is a template. I'll show you how it's working once I show you the functionality of this. If I start it, okay, I've started motor 1. You can see that my motor temperature is rising because the motor started. It's trending over here on this graph. You can see that I think this is a 10-minute viewing window, so it's going to in real time update as time goes by. Or maybe this is actually a 2-minute. I think my aux content is longer. Aux content, this is simulation code that I wrote to mimic the aux contact of a motor contactor. So when I click start, as long as I don't have a fault, I will send the command to pull in the coil for that contactor. Then I'm simulating that, hey, when I say the coil is pulled in, the aux contact is shut, and I'm trending the status of my aux contact. And this is really more just to show you how you can use templating and indirection through buttons to create one set of objects and then pass, just like in function blocks, pass different data through them. So you're not having to create, if you've got 3 motors, you don't have to create 3 content files, one for each different motor. The idea is we want to create one content file, or we want to be able to reuse as much code as possible so that we cut down on our development time, and so we don't get into the rabbit hole of copying and pasting things and mistyping when we need to edit something that we've copied, and it makes troubleshooting easier. So I'm on motor 1. If I go to motor 2, you'll see that I clicked motor 2. What this does is it creates this button has an event listener on click, and that's going to pass different values to my user control, and it's going to pass different values to my my trend lines. And so you can see that this motor is off. Motor 1 is still on, it's updated. Motor 2 is off, and motor 3 are off. Okay, so if I go to motor 2, I want to start that one. I want to go back to motor 1. I want to stop it, and you'll see that my temperature is falling off with my simulation code, and also my aux contactor is now open. My aux contact is open. But that hasn't affected the data that I'm showing on my motor 2. And now another important reason to try to reuse as much code as possible and to limit the amount of controls you have on a screen is you have to remember that this web application, if you're running it on the same Windows, if you're running it on the same system that you're running your PLC, the web server is going to have overhead. It has to draw these objects on the screen. It has to use RAM for the web browser. It has to use overhead for communicating back to the PLC. And the PLC is also using resources because it's running its PLC code. So if we've got 10 motors or 100 motors or whatever, we don't want to have 100 instances of charts and user controls and all these things, because that's a whole lot of overhead that when we're trying to mass produce an OEM machine, we don't want to have to pad that price into, a higher level PLC, a higher level, more RAM, more cores, because, with Beckhoff, if you're familiar with Beckhoff, as you move up in performance level with your hardware, your licensing scales also. So this is all to say that thinking through a good architecture for how you want your HMI to work is going to get you the most out of your hardware. It's going to get you a competitive price when you're quoting if you are an integrator. And also it's just going to really make your time investment much less because you can reuse all this code. So I'm on motor 2. If I go to motor 3, I'll start motor 3. Motor 1 is off. You can see that my temperature has dropped off. Also my aux contact is open. Okay, so we get the idea of what's going on here. I'll just show you what happens when we come in here real quick, and I'll go to my runtime and I'll fault out one of these. So essentially the functionality is that if the overload for the contact were to if the overload were to trip, we would go into a fault state. So we'll see that real quick. I've got a global variable list for inputs. I like to split out my inputs and outputs in a global variable list. Motor 2 is running, which we can see the aux contact is shut. So I'm going to write a true value to my overload. Okay, my overload is tripped. My aux contact is now open, and you can see that temperature is dropping off. And if we go back to the HMI, we can see that, okay, well, our motor state is now faulted. It's red. And everything else has followed suit. And we'll stop motor 3. So now, this fault reset is just essentially, I give a fault reset command from the HMI. I want to reset if I've got an electronic overload for my motor. I want to reset that overload, and I want to say I can run again. So I hit fault reset. Okay, now we're back to the off state. Okay, so that's what we're working with when that's the functionality of this HMI project that we've got going on. And then another thing I want to show you is if we click over to the event log page, you can see that I've written messages for as I work through the different states of my motor control function block. So I've got 3 instances of a motor control function block, 1 for each motor, and then I've got messages, a TC message inside each of them that I send out when I change state. So if I go from off to running, I create a message. Running to off, I create a message. If it's faulted, I create a message. Now the great thing about this is all I had to do was write the PLC code. All I had to do was write the PLC code to handle generating those messages. And the event grid, which is a built-in control in Beckhoff, in the TwinCAT IDE, the HMI IDE, this plus installing the event logger extension, which is free, this natively brings in all these messages. And what's really cool is I can double click these and I get more information. So from a troubleshooting aspect, this is awesome. If you want to be like to create a commissioning mode where all of these messages are active during commissioning and then they're hidden away from the user once you fully commissioned, it's really a good system to do because I can go in here, I can click on my message and it will tell me exactly the source where that message came from. So it says main, my main program, and my function block instance motor 2. So I know exactly, hey, this message came from this place. If I need to investigate why this message came in when I don't think it should have come in, or I didn't get a message when I thought one should have come in, this is telling me exactly where this is coming from. So I really like this functionality because it makes alarms so easy. And so this is just a message, so a TC message type. There are alarm types that you create in your type system. There's an entire manual based on that. If you'll Google the Beckhoff event logger, it'll show you all the PLC API, which has all your function blocks, your interfaces, how to walk through creating alarms, warnings, messages, errors, and this event grid is, you can filter it natively. So I don't have any warnings or alarms or errors created, but if I did, they would show up and you would have a number in this spot right here that would show you, how many you have of each. And you can also filter these out. So I can drop my informational or my messages away and it dynamically filters what I'm viewing on the screen. So it's just really cool. I mean, I love it. And then if I had alarms, this is your confirm and confirm all. So if you had alarms, in the event log, the way that alarms work is they go through a state machine. They're raised, confirmed, not raised, confirmed, or cleared. And so if you wanted to confirm alarms, if you've got an active alarm that's on the screen, you could confirm that one single alarm, or you could click this double check mark and it would confirm all your alarms. It would send them all to the confirmed state. And then your PLC code could handle, clearing out those alarms until they're triggered again. So really cool stuff. I really enjoy it. Like you saw down here, I've got my TwinCAT ADS runtime control. So let's see how this is actually working. How I made this happen. Okay, so the most complex part of this HMI is the motors page. So we're going to focus on the motor content file to see how I've dynamically passed around the 3 different data sets for each of my motors, and got them all to display in one temperature chart, one aux contact chart, and one user control for my start, stop, fault reset, and changing the colors of my motor image to show the operator what the state is. Also important note, on these charts, you can have multiple symbols charting at the same time. So like one of the projects we just did, we had a really high number of heaters that we were using SSRs to control, so we could get different percentages of power sent out to resistive heating elements. So usually I have a set point that I'll trend, and then I'll have the actual temperature. So the operator can look in real time and say like, okay, well, this is my set point. This is what I'm actually at. It's also a great way to tune PIDs. You can use the scope if you've got a very fast loop constant. But if you have a slow process, you don't need to see it at the 100 millisecond or 10 millisecond rate. You can see it on a larger time cycle. And so you can use your built-in ring buffer via the SQLite Historize extension to display this data. So it all starts with creating my user control. So if we're on this content page and I know that I've got this user control, I'm going to go over to my my user control section. So I'm going to go back to my HMI project, come down to user controls. This is a folder that I created myself. I like to have everything in folders. So I recommend if you're going to have a whole lot of user controls, which I would recommend you do because it makes templating very easy, I would create my own folder for that. And then you can see this UC motor control. I'll pull that up. Okay, so I have my motor control, my user control that I'm calling UC motor control. This is, in the document outline, this is the parent, and then these are all the children or all the elements, the controls that go inside of it. So the most important part of controls is parameters. So parameters, which if you click this little P icon over here to the right, that's what brings up your definitions of the parameters that you're going to pass into this user control. So think of these as input outputs, var in outs. This is the interface by which you can indirectly address and push data into these user controls so that one user control instance can represent many different data sets as you push them into it. So what I've done is I have a data type called ST. See if I can get this thing to spread out. I might not be able to, but I've got three parameters. I've got this is the local variable name, so ST motor status, ST motor command, and S motor title. And because I mapped these from my PLC, let's see, yeah, down here. So if we look down here, we can see that when I mapped them to my PLC, or rather, when I mapped the symbol from the PLC to the HMI server, it created that type. It said, okay, I see this structure, and I'm going to create this type, and now I know how to use this type. So that's really nice because I don't have to bring in a bunch of individual variables. I can just bring in the entire structure, and then I can use the different elements of that structure in my user control. So I've done this. I have a motor status, which isn't what I call an HMI status. I have a GVL for HMI statuses. I have a GVL for HMI commands, a global variable list for both statuses and commands to keep them separate. And then I've made structures so that it's very easy when I've got my function block for my motor control. I'm using structures, so I have to type one variable for my motor commands and my motor statuses, rather than typing, the symbol name for motor start, motor one stop, motor one fault reset. So that's a major takeaway when you're really in any HMI building and programming in general, which I do not claim to be an expert programmer, just a guy that figures stuff out. I think it was. Oh, Lord. I'm going to forget the name of the programmer, but he basically said, if you get your data structures correct, then everything else is easy. And I really do believe that. If you take a second and draw out the architecture by which you are going to push around data and you put it in a repeatable, understandable way, that doesn't take a lot of keystrokes, but is not so abstract that you get lost in the code, that's really how you're going to be able to quickly create great HMIs and create large projects quickly. So, sorry for that tangent, but I've created a structure for motor statuses to the HMI. I've created a structure for motor commands to the HMI. And then I just have a simple string for the motor title. That's what you see that gets dynamically changed that says motor 1, motor 2. Okay, so let's see. in the parameter page, you can have default values, default internal values. I don't have that stuff set up, but you can set up these sorts of default values when they're first called. So when I click on this stuff, so when I click on these controls that make up my user control, this is an image, and if you see over here in the document outline, if you see a little lightning bolt on one of your controls, that means that there's an event that is attached to that control. So it's an easy way to see, hey, which controls do I have that I have their properties bound, meaning maybe I bind to the height of an object, to the height of a user control. That property, maybe I bind that to a symbol because I want to change it for some reason. I don't know why you would, but maybe I want to change the height of a symbol dynamically. You can bind that to a symbol, or you can have an event that acts on that property, that height property. And if you do use events, it's just nice to look over here and say, okay, well, I've got an event for this user control. At the highest level, I have an event. And if I look at it, this yellow means, the yellow P means it's a parameter. So what is triggering this event is a change in state of my parameter. And this parameter is the ST motor status that we just saw. It's the ST motor status enumeration for motor status. And if we look through my code, what we would see is that in that structure, I've created an enum that represents the 3 different statuses of the motor. So it's an enum for running, off, and faulted. And so what I'm doing is I'm saying, if there's a change in the value of that enumeration, let's say if we go from off to running, running to fault, fault to off, whatever, I want to trigger this configured event. And if we click on the pencil, we can look at what that event is. And, pardon me, I got my thing all messed up. That event is just an if statement. It's an if statement. So I brought over a conditional. This is, these actions over here is what you can use in events. You can use the template that they've got out here for you. So condition, switch case, write to symbol, or you can write JavaScript, or down here you can do functions. And there are built-in functions like binding, which we'll see on the chart. There's also custom functions that you can create. So fBitmask is a custom function that I created. It's a JavaScript function that works inside the TcHmi framework. And it doesn't matter what the scope of that function does, but just know that if you have some function that you want to use repeatedly to change the properties of an HMI control, you can write custom functions and use them here. And then you would just drag and drop them over into this work pane in the middle. So what I've done is I've just said, hey, if the motor status is a fault status, then I want you to act on the motor image, and we can see over here my controls that are in scope and my controls that are out of scope. So my controls that are in scope are controls that live inside the UC motor control user control. And so this image right here is inside that scope. So I open it up and I said, well, what do I want to act on? I want to act on the background color of that image. So I just drill down in here to colors, background color. I dragged and I dropped this over here, and then it just gives you a value to set it to. So I set it to, open this up, you've got none, theme color, solid color, or gradient. And I said, well, I want it to be red. If I'm in a fault state, I want to change the background color to red. And it's the same thing on down through here. If I'm running, I want it green. If I'm off, I want it, white. And this is the parameter. Remind you, this isn't a directly bound symbol in the PLC. This is a parameter in the HMI that we're going to pass PLC symbols into. And also, it's really nice to know that because when I mapped this motor structure that contains that enumeration, my drop downs over here automatically correspond to what that type is. So you don't have to worry about like, well, what was my integer 1 for my enum? What state does that represent? It's a really nice thing to do is to map your symbols over, because then those data types are reflected in the HMI project. So I know exactly, well, I want fault status. I can click fault status. It's really nice. It's a very cool feature. So that's how we're changing the background color. this parameter for the motor set that I'm passing in. When it changes its enumeration state for the motor, it's going to act on this background color off of that conditional. Over here, I have a text block. If I go to properties, you can tell that I don't have any events because there's no lightning bolt over here. So I must be getting the value for that temperature. I must be acting on a property. And if I scroll down, I can see in this text block, if we look over here, it's a type TcHmi controlled text block, meaning it displays text. And over here, it says common text. Okay, so under the common class, we have a text property. And if we click on this, what I'm doing is, because I'm not displaying necessarily native text, in the PLC, I have a real value. And as we know, a real value, not every floating point real value has a nice terminating decimal representation or binary representation. So, you do like a 1.333, and it turns into this long mess at the end of it. So what I did is I used a built-in function called the gauge value formatter that accepts a number, and then it accepts an argument for the number of decimals you want to display. So what this is doing is it's going to take that number and it's going to truncate it to the number of decimal places I want, and then that will nicely display in the text field of my text block. And so again, this is indirect because I'm using a parameter. I'm using of that motor status parameter that I pass in, one of the elements is a floating motor temperature. So again, this is indirect. This motor temperature, that's just static text because it's just a label. So it's a text block with, down here you can see it's hard-coded motor temperature. And then now let's look at my start and stop, okay? So start, same idea. I passed in, as you saw in the parameters, a structure for motor commands, so commands from the HMI. And so on my state symbol, if you hover over the state symbol, it will tell you what that property does. And that property, it tells you a symbol of type Boolean, which will be set to true if the button is pressed, and false if the button is not pressed. So because I'm not maintaining the state, I'm letting the PLC maintain my state. I just want to know if it's been pressed once, I've given the start command. If stop has been pressed once, I've given the stop command. So this again is just a parameter. Same thing with stop. Same thing with fault reset. So when this button is down via a mouse click or via a touchscreen input, it's going to write that value of true when it's pressed and false when it's not pressed. So that's how we've built this out. And then if you look at, this is the motor title field block. It's empty right now because you can see that in the text property, the parameter that I have is the motor title, and the default value for that is an empty string, so nothing is showing up. But you'll see that when we click the motor 1, 2, or 3 in the motor content page, that's where I'm passing in the real data sets, the actual data sets. I'm passing them into these parameters, and that's what's going to dynamically update these properties in the user control. So I hope that's been a decent explanation. I'm sure I butchered it, but try my best. So back on the motor content, this is where we get into how we pass in the right values to those parameters. So we just went over this user control. If we look at the user control properties, you'll see the first 3 things are those parameters I was just talking about. The user-defined parameters that I defined in the user control. So they're right there. You'll notice they're not bound to anything. If they were bound to something, if I right-click this, I could do data binding. That means link it to a mapped symbol. I haven't done that. Or create a function binding. You can create it. You can map it to the return value of a JavaScript function or a built-in function. I haven't done that. The reason for that is because my buttons up here, my motor 1, 2, and 3 buttons, are the ones that are dynamically passing the data through event listeners. So again, if we look over here on the buttons, you can see there's lightning bolts. Those lightning bolts, if we click them, it will take us right to the events for that particular control. So button motor 1 is my identifier. I come down to on pressed. What am I doing when I'm on pressed? Okay, so on pressed, I'm going to write to the symbol UC motor control, S motor title. So this is the parameter of my UC motor control, S motor title. And I know that's a mouthful, so it makes it easier if you look over here in your controls that are in and out of scope. My controls in scope, because now we're on the content page. So any control in the content page is going to be in scope, so I can drill down inside them. So I go to my UC motor control, I drill down inside of it. Okay, well, I'm looking for parameters. So I go to parameters, and I can see these are my parameters: S motor title, structure ST motor command, ST motor status. If I drag and drop them over, which is what I've done, now I can write to that symbol a value. So when I click motor 1 button, I want to write the string motor 1 to the S motor title, which will then go into the user control, and it will do what the user control does, which displayed in that text box. The next two are a little bit tricky, because the next two are how I actually pass in the HMI status. So the status of the PLC. So is my overload tripped? Is my motor running? The enumeration, the temperature, the status is back to the HMI, and then also the structure that is the commands from the HMI to the PLC. This is a little bit more tricky because I don't want to just write a symbol to that property, to the parameter. Because when I write a symbol, if I just did write to symbol like I did for this S motor title, and I put in here the ST, I'll just drag it over here so you can see. So if I just did this, and I said write to symbol ST motor status, and then I said, okay, well, I'm going to bind this to a symbol. So I go to create data binding, and then I go through my mapped symbols. So symbols that I've already mapped from my PLC. If I were to click on my motor status, this little icon right here is just telling you that that's actually being historized, it's being recorded. If I clicked that, what this is going to do is it's going to pass by value. It's not going to pass by reference. It's going to pass by value to the parameter for the user control, the values of this PLC symbol. And I don't want that, because for statuses, it's not such a huge deal, but for commands, it is a big deal, because when I go from clicking button 1 and displaying the user control data for for motor 1, when I click start and stop, I only want that to act on the PLC variables for motor 1. And so I need a pathway back into the PLC, and you can't do that by value, right? Because when you're passing by value, you're just saying, hey, this is the active value for the structure. I'm going to pass this into this user control, and it's going to display whatever the active value is at the time that you triggered that event. It's not creating a living binding that is updating as time goes on. It's just saying you triggered an event, you pass the values into this user control, I'm going to display the values at the time that they were passed in, and there's no link back and forth between the HMI and the PLC now. So what you have to do, rather than just binding it to the symbol and passing by value, what you do when you need this kind of functionality, there's plenty of times where just passing by value is fine. There's plenty of times where you just say, right now I want you to display for one instant what this thing is. I can't think of a use case, but it exists. But when we want to create a living connection dynamically, we need to create a binding. And so that's why what I've done is I've gone down here to functions. I've gone to binding and create binding. I dragged and dropped this over, and now I can parameterize my binding. And so what you see here is that I have created a binding to my UC motor control, which is over here. UC motor control is the identifier for the instance, the real instance, not the prototype, not the template, but the real instance that I have. And then I've said, well, what property do I want to create a binding on? Well, I want to create a binding on, for this first one, I'm creating it on the motor commands, so the HMI commands back to the PLC. I want to create a binding in that direction first. And what symbol do I want to create that link? What PLC symbol do I want to create a living binding back to the HMI on? And of course, it's going to be this PLC GVL HMI command structure motor command 1. And it's motor command 1 because right now we're looking at the button events for button 1. That's for motor 1. So I did this create binding function. Same thing for my motor statuses. I went down here, I did create binding, except this time it's still the UC motor control. It's still the instance of my user control, but it's the parameter that I want to act on is now it's the motor status. So you can see ST motor status. And now the symbol that I'm creating the living binding on is the PLC HMI status, ST motor status 1. Okay, so I know that's convoluted and I apologize for not explaining it well, but that's the difference when you want to create these dynamic objects that have living bindings that go back and forth and they're updated as scan cycles go on. They're not just updated when the event is triggered. So it's not just that I'm passing by value when I click the motor 1 button, but it makes a binding between the HMI and the PLC throughout time until I click another motor button. That's how you do it, is with this check binding function. The next two, what I'm doing is a little bit deeper. It's in the trend line charts, and that's passing in the correct data set that I want on the trend line chart. So obviously when I click motor button 1, I want to pass in the temperature for the temperature chart of motor 1 temperature. For the aux contact state, I want to pass in the aux contact state of motor 1. And so what I've done there is I have, again, in my dropdown, I look at my controls in scope, and I see I've got my trend line chart from my motor aux, and I've got my trend line chart for my motor temperature. Drag and drop those over. Well, actually, correction. You drill down in first, and you find out what you need to act on, the property you need to act on. The property that I need to act on is the common and line graph description. In the trend line chart, the line graph description is the definition of the symbol or symbols that you want to display, that you want to track. There are different properties, configurations for your y-axis and your x-axis, but when you're actually passing in symbols to trend, you do that with the line graph description. And so when I click on the motor 1 button, I want to dynamically pass in to the motor temperature, to the motor temperature trend line chart on the property line graph description. I want to pass in if we click this ellipsis, these 3 dots, it shows us what we're passing in. And what I'm passing in is this configuration, which is I want my color to be red. So I want the line to be red that I'm displaying on the chart. And really the more important part is, well, what symbol are you binding this to? Well, the symbol that I'm binding it to is my HMI status motor 1 temperature. So this is where you dynamically do that. And then this is just more, everything else in here is just configuration on what you want it to look. Do you want to plot points? So if I'm sampling this symbol at every 1 second, and remember, to use this in a trend line chart, the symbol has to be hysterized. So it has to be mapped to the HMI first, and then you have to have gone through setting up the hysterization, if that's even a word, settings for that symbol. And that's okay, because if you were to try, if I click this and I say select hysterized symbol, TwinCAT automatically filters out, the XAE automatically filters out any symbols that are not hysterized. So you'll very quickly, if you're looking for a symbol and you can't find it, that's because you haven't set up the historical settings for it. So that's how I pass in dynamically the temperature. It's the exact same protocol for the aux contact. I click over here on the trend line chart for my aux contact, and you can see that the symbol that I'm binding it to is my GVL inputs motor, ST motor 1 in, and it's the aux contact element of that structure. Okay, so that's how I'm dynamically passing these values around. Button 2 and button 3 are the exact same templates. If we go to the events, you'll see for motor 3, for the button for motor 3, you see the exact same events over here. The exact same event listeners are configured, and the exact same steps are laid out in this event. The only difference is that I've obviously changed the symbols and the bindings. So for this is the motor 3 button, so I want to pass in a string that is motor 3, and then I want to bind these symbols to the data sets that are responsible for a motor 3 status and motor 3 commands. I think that's really a lot of essentially the high level stuff that I've done and tried to show you as far as templating comes down to. If I click on the user control instance for a trend line chart for my motor temperature, you can see all of these parameters down here, properties for the control. And some of the more common ones is your default start time and your end time for a trend line chart. So for my temperature, I want to end at my latest time, so like right now, and I want to go back in time 2 minutes. So PT2M, that's 2 minutes back in time. And then that 2-minute window will just keep updating as we go through. And you can see that the interval that I've set this up at is 1 second, because this is in milliseconds. So 1,000 milliseconds is 1 second. And you can also see that this is this line graph definition right here. This is the property that we're acting on via the buttons over here. So again, thinking about this, going back to the TcHmi framework and the code behind that we saw when we looked at the raw JavaScript code, these are just event listeners and properties that you can act on. And so while you can click on the control and parameterize the control statically, meaning one time you can, type something in and say, okay, well, you're always going to be this value, or you can bind it to a symbol. You can also, like we just saw, have other controls that trigger events that act on the properties of other controls to give you dynamic functionality in your HMIs. And so getting that kind of process, thinking about that process is really what makes you able to quickly generate these HMIs. And again, x-axis configuration, you can define how many sub-ticks you have. So you can see I've got 2 main ticks. So I've got a big tick and 2 large ticks at the beginning and end of my x-axis, and then there's 4 little ticks on the inside. All these properties, you can just go through there and you can customize them however you want. You can set up themes, you can set up classes so that, if I assigned a class, if I defined a trendline chart class that had all of the property configurations that I wanted, as far as like stylistic, as far as fonts, all these things, then I could just bring over this control, drop it into my workspace, and then assign it the class. You'll see this class name right here. If I had classes defined, I would have values over here that I could click on this right arrow. It would populate over here, meaning that it's been attached to that object, and immediately all those configuration parameters are now put onto that instance of the control, and so it's very quickly you can get, instead of having to go through 10 charts and give them all the same fonts and everything, you can just do it in one click once you do the work of setting up those classes. A guy named Oleg Mueller on YouTube, he has great videos on a lot of really cool stylistic and CSS things and themes that you can do. I really encourage you to check out some of his videos because he's got really cool stuff on how you can kind of set up those classes and set up themes for working in an HMI project. But I think that's mostly what's going on here. Let me check. One other thing to bring to your attention is you'll see that in this content page, I have an event on the parent object. So the content file itself, I have an event on. And you'll see because different controls many of them have the same event listeners, the same events over here, but some of them have different ones. And you'll see this on attached. And so on attached, if you hover over it, the attached event is fired before a control is added to a view. So this is important for when you want to set up default states. So the first time a web client targets that browser, or first time a web client targets the URL endpoint and the view is loaded, this on attached event is a good way to set up all, without the user clicking on anything, without them clicking on this motor 1 button, what do I want to show them when this content is first displayed on the screen? And so that's what I've done here. I just go to on attached, and this is just a copy and paste of the button 1 events, because I've said that, hey, when someone navigates, when they click on the nav bar, when they click on motors, and the motor content is loaded into the main region of the desktop view, every single time I just want to show them what motor 1, I want them to start at motor 1 data sets. You could have it so you remember. You can set up, there's internal variables and server variables that only live on the server that you can use for for your HMI logic, and you could set something up that says like, well, remember the last data set that they were on before they navigated away from the motor page, so that when they went back to it, it showed them the same motor that they were on. You can do that. You can do whatever you want. But I've chosen to do it via the onAttached event, that every time it just shows the motor 1 data sets. So if we go back to our HMI, I mean, I think, this functionality, I think you can kind of see what we've talked about. This is one user control that has parameters. As I click on these buttons, I am triggering an event that is going to pass, it's either going to pass by value the motor title, so it's passing this motor title right here, or it's making a binding, a living binding, so pass by reference, that's linking between the PLC and the HMI, so that, as I start and stop these motors, it's retained. The motor temperature is the same way. I'm passing in the status of this motor value. And then these trend line charts, you can see it's the same way that with these motor buttons, I'm just passing the data set. I'm passing the symbol that I want displayed in the line graph description of each one of these charts. When I click the button, I just pass a new symbol into the property line graph description for that trend line chart. And now it's gonna trend it in real time based on the settings for that trend line chart. And I don't have a menu up here right now, but there's a property that you can click on a trend line chart that lets you pause it. And when you pause it, you can zoom in. And when you zoom in far enough that you're at the resolution of your sampling time, so I'm sampling this every 1 second. If I zoomed in far enough that I could see, the seconds, then I would have dots that would show me and show the operator, hey, every one of these dots is a confirmed saved value from the PLC. Anything in between those is just an interpolation, right? Like, that's something that we need to be mindful of, is if we're recording a historized value at a 1 second interval and we zoom in, we get to 200 milliseconds, there's 1 second of dead time between samples that we can't trust that value. It's just a graphical interpolation between those 2 points that would give you a nice slope. Anyways, it's just something to point out. Sorry about that, my camera died. So the last thing I want to show you is the TwinCAT HMI Windows, so the different windows that come when you install the TE2000 package. And we'll start off with the TwinCAT HMI configuration. This is where all of your symbol mapping is. So you can see that we're on all symbols, and it shows via ADS the target systems you have connected. So PLC1 is the name of the PLC that I've named. If we go to map symbols, you can see the subset of all symbols that you've actually mapped. So all symbols, obviously it's got all my global variable lists, everything that is that can be discovered via ADS. And then my map symbols is a smaller subset of those symbols. And you can see that these last 6, I've got this little time clock next to it, and that means that they've been set up for historical recording. And to adjust the values of that historical recording, you can go to Historize Settings, and it will bring up, which public configuration do you want to save these symbols for, the max number of entries, and then the periodicity down here for how often do you want to save them. And those have to be, again, to have historical recordings of symbols, they have to be mapped. You can't do that. You can't record history on symbols that are not mapped. And then again, if we go into Historize Symbols, it shows those by themselves. And then internal symbols, I don't have any internal symbols created for this HMI server, but you can create symbols that only exist in the server. And some useful functionalities for those is like constants. If you wanted constants for Boolean logic, where in your conditionals you need an always true and always false, or something that changes state, you create an internal symbol for that. Also, sometimes when you're moving objects out of view of the operator, sometimes I'll set up a constant integer that's a position for either left or top or bottom. That's a positioning, a layout property. So I'll just use that constant. So when I'm moving controls into the screen or hiding them from the screen by moving them out of the viewable space, it's always going to the same values, and I don't have to, hard code an integer for that. Another useful screen, or another useful window under the TwinCAT HMI is the document outline. This is how, if you had lost your document outline on your screen, you could go to TwinCAT HMI Windows and then document outline. And this is the document outline that appears over here that shows all the different elements on the content or whatever control you have pulled up. Also, we have the live view, and so live view, again, this is what's targeting the engineering server. So if you go to TwinCAT and then Windows, then live view, that will bring up basically the engineering server preview that shows your non-production web server, so you can test out everything, make sure it's working before deploying it to your permanent production web server. And then the last thing I want to show you really quickly is the HMI project properties. So these are the project-wide properties that affect how the project's going to interact with the PLC and how it's going to load when you first open a web browser. So if you click on the topmost entry in your hierarchy for your TwinCAT HMI project, you'll see in the right-hand side the properties bar, and you can see like what's your default viewport size, binding symbol error handling, how these things are done. If you're going to be on poll, if your subscription method is poll, then it's the millisecond interval that you want to poll the PLC for changes to map symbol values. You can also do subscription mode on change, so that when values change in the PLC, they're automatically pushed up to the HMI server to refresh the value of that symbol. One thing to note about on change is that if you're dealing with Booleans, that might make a lot of sense because oftentimes those change much slower than analog values. But if you have an analog value, most real values or real data types in a PLC are going to change really rapidly, simply because there's some error between the rounding and how the binary representation of a floating point number. So if it's on change and you have very, very small changes in that floating point symbol, that's going to be pushed up to the HMI, and that might not be desirable because the changes are so small that it doesn't matter to the operator. So it's just something to think about when you have a lot of analog values and you're using a subscription method of on change, that you could be generating a lot of HMI refreshes of those symbol values that aren't really needed. And then again, this is going to be based on the hardware that you're running. What's the communication overload? How much system resources does it have that's available to communicate back with the PLC? How many total symbols are you bringing over? So that's really going to be based on your specific implementation. And then these properties down below are more just company name, company's website, your scale mode. That can be important when you're working with different view sizes. If you're working with an HMI is going to be displayed on a desktop computer, but then also on a phone or on a tablet. So these are just some of the properties to note that affects the entire project.